Welcome to this explainer. We interact with the internet literally millions of times a day. We generate something like 300 million terabytes of data daily. Crazy, right? But behind all that digital magic lies a massive, complex, and honestly, largely invisible infrastructure. Think of the internet as this globally connected, incredibly highly efficient restaurant. Today, we're taking a full tour, right from the front door all the way back to the kitchen and the maintenance rooms. Okay, let's dive into this. Have you ever actually stopped to consider what exactly happens behind the scenes when you tap a link on your screen to shop or download music? It's completely seamless for us as users. We type in an address, we hit enter, and boom. Instantly, we're presented with articles, videos, or our shopping carts. But making that instantaneous delivery feasible? Well, that requires an incredibly coordinated dance of hardware and software. To make sense of all of it, we're going to break the complex backend of the internet into four digestible layers. Demystifying the web server, choosing an operating system, web versus application servers, and finally, the power of utility programs. Layer 1. Demystifying the web server, or as I like to call it, the front door. So think of the web server as the front of house host stand of our internet restaurant. It's the very first point of contact. The term server gets thrown around a lot, right? But fundamentally, a server is really just any computer used to present or serve files and programs to other computers on a network. And those other computers, like your phone or your laptop, are called clients. Now, the tricky part here is that the word server can actually refer to the physical hardware itself, the software program running on it, or honestly, both of them working in perfect sync to serve files across a network. Now, what's really interesting about this slide is that it's super easy to forget the cloud is actually grounded in reality. Like, behind all that digital ether, there are actual physical computers housed in these massive, heavily guarded data centers. A hardware server is a real, tangible machine. It's got a CPU processor, memory, and hard drives storing all the actual component files of a website. Without this absolute physical foundation connecting to the network, no data could ever be exchanged. Once we have that hardware in place, the software dictates exactly how those files are served. And this basically comes in two main flavors. A static web server is relatively simple. It's just the hardware and an HTTP server, and it sends hosted files exactly as is straight to your browser. A dynamic web server, on the other hand, well, that adds some extra software into the mix, like an application server and a giant database. It's called dynamic because it literally updates the hosted files before sending them to you. Think of massive sites like Wikipedia. Instead of hosting millions and millions of static HTML documents, they use a few templates that are dynamically filled with content from a database the exact moment you ask for it. Pretty smart, right? So, what is the exact journey of a single click? When you type a web address into your browser, the browser is essentially asking the internet to find that page. A domain name system, or DNS, steps in and converts that human-readable URL into a unique identifier, an IP address. That specific IP address points directly to the exact web server holding the content. And finally, that web server processes your request and presents the website content right back onto your screen. Moving on to Layer 2, choosing an operating system. This is the management. If the servers are the restaurant, the operating system is the absolutely essential manager. The foundational software on literally any server is its operating system. Without this critical software handling things, a server is really just a very expensive collection of electronics that has absolutely no idea how to communicate with the rest of the world. The OS performs all the fundamental tasks. It handles memory management, process management, input and output, and it controls all the peripheral devices like disk drives. Literally everything else you run on a server relies entirely on this foundation. When setting up a web server, administrators always face this age-old question: Linux or Windows? Looking at it objectively, Linux is open source, completely free, highly customizable, and generally provides more robust security, which makes it highly efficient with much lower hardware costs. Windows, conversely, is closed-source proprietary software. It does have higher hardware costs and consumes more server resources, but, and this is a big but, it is absolutely necessary if a company relies on specific Microsoft technologies, like MS SQL databases or the ASP.NET framework. So both definitely have their distinct places in the market, depending entirely on a company's specific compatibility needs. Section 3, Web servers versus application servers, the front of house versus the kitchen. So the crucial point is establishing the boundary between the servers taking the orders and the servers cooking the food. While these two terms get used interchangeably all the time, they actually have very distinct roles. A web server's fundamental job is to handle HTTP protocols and fulfill client requests for static content. We're talking basic HTML pages and images. It consumes fewer resources and doesn't actually support multithreading. An application server, however, that is the heavy lifter. It exposes the business logic to client applications, meaning it generates dynamic content and runs complex enterprise-based applications. Because of this, it utilizes way more resources, has a far higher capacity, and fully supports multithreading to handle complex, simultaneous tasks. Often, they're deployed right alongside each other. The web server takes your order at the front, and the application server cooks up the dynamic results in the back. And finally, Section 4, the power of utility programs. Let's meet the maintenance crew. And this brilliantly illustrates our final piece of the puzzle. If the OS is the manager and the servers are the hosts and chefs, utility programs are the invisible maintenance crew keeping the entire operation optimal and virus-free. They execute highly specific tasks for the health of your system resources. You've got your system utilities handling critical security with antivirus and firewalls. File management utilities take care of data archives and software backups. Storage device management handles formatting, disk space allocation, and disk cleanup, just making sure you don't run out of room. And then miscellaneous utilities cover the rest of the whole shebang, from data generators to HTML checkers. They're all just working quietly in the background so the servers can focus entirely on serving you. So we've walked through the physical hardware, the intricate software, the foundational operating systems, the dynamic application servers, and the utilities that maintain it all. It is a massive, highly orchestrated process happening globally, millions of times a second. Next time you click a link to buy a product, download some music, or read an article, I want you to challenge yourself. Take a quick second to think about the incredible complex dance of operating systems, hardware, and dynamic servers answering your call instantly from somewhere else on the planet. What invisible infrastructure are you interacting with right now? Thank you for joining me for this explainer, and keep questioning the technology that powers our world.